This is going to be the last session of DevNation. It's awesome. So it may go fairly quick to give you guys a chance to get out and to do something else.
I hear is there free beer in the partner pavilion? Did somebody just say that?
Yeah, there must be.
Beer.
Free beer.
All right, excellent. Rob and I are never ones to stand in between someone and free beer, but we do have some cool stuff to discuss, so it'll be fun. Actually, it's given the intimate setting, we're happy to take questions during the talk as well. So if we say something that you think is absurd or false, or you think you have a better idea, feel free to actually chime in. It would be cool to just have a ongoing Q&A. No need to wait for the end. Okay, so today we're going to be talking about IPaaS, or Integration Platform as a Service. And so we should probably give a quick overview of what that means, right? Like, what is an IPaaS? And we're not going to spend a lot of time at this overview level, but we just kind of paint the overall picture. And then we're going to get some really cool stuff like under the covers, real gritty, developer-oriented stuff. So good stuff ahead. So when we talk about IPaaS, we actually designed what we affectionately call the wheel of IPaaS, which I will show now. So the first property of IPaaS is it's as a service offering, right? Actually, real quick, before I even continue, how many people were in the integration roadmap talk on Tuesday? All right. Enough that I can reuse my jokes. Excellent. So it's tough to come up with new ones. OK, so it's an as-a-service offering, right? It's in the cloud. You don't install something locally. You want to go to a service provider and actually just sign up and have IPaaS available to you. So that's one thing. Now, does that mean it's only public cloud-based? Well, we'll talk about more of that in a minute. But for now, we know that being hosted in the public cloud is a key attribute. The next thing, of course, is its integration platform as a service. And really, there's two flavors of integration. The first one that if you know Camel, if you know Fuse, that you're already familiar with, of course, is enterprise application integration, right? So connecting systems and APIs together, doing basic routing and orchestration, data transformation, all these core integration capabilities that Camel and Fuse are totally awesome at. So that's one piece of this. And the next piece actually is data. So the need for data and interacting with data stores doesn't actually go away when you move to the cloud, and it doesn't get any easier. You have all these funky cloud stores to deal with, and then you have the on-prem stuff too. What's the security around that? How do you federate that data, keep it in sync? These are really significant problems that have to be solved in a new way in an IPaaS.
So Keith, we really have to do that as well?
Ish. Yeah.
Okay.
It turns out actually we have some excellent projects that do that too, yeah, right? Like TIA and DataVert, right? And they're coming on the XPaaS train, so we're going to have images soon. So there's all goodness there. The other aspect of this is cloud connectivity. So you're running in the cloud. If you're looking at an IPaaS, you're likely another SaaS user of a bunch of other stuff, like Salesforce, NetSuite, Workday, bunch of other SaaS-type apps. And you want to connect to those types of apps. Some of those might even be social, like Twitter and LinkedIn. You might have a bunch of storage or services on Google with Gmail connectors. You likely have infrastructure stuff and maybe even messaging or storage on Amazon. And you want to interact with these sources when you're in the cloud, in addition to when you're on-premise. And as you're deploying all of these integrations, how are they going to talk to one another, and how do they interact with the outside world? Well, they're going to do that across boundaries. If it's in the cloud, right, it's being deployed independently, it's public, you're going to expose that as an API, generally a RESTful API, because SOAP's a little bit out of fashion, right? Still valid, right, but most people are on the REST train nowadays. You think? Yeah? Yeah. All right. Thumbs up from Rob on REST. So exposing APIs becomes a big deal, but then also managing those APIs, right? So now we've got all these, our developers are throwing up APIs left and right, and we've got all these APIs all over the place. Well, what are we doing for security? Like, how do we actually monitor these things, right? How do we understand which ones are being invoked if we're going to take something out of service? Do we know which clients are using it, how often they're using it? These are big problems to solve, and they make a lot of sense in an IPaaS-based architecture. Next piece is cloud-based toolchain. So this is cloud-hosted software, right? You don't install or configure anything on your own. You're actually using it in the cloud. well, you're probably going to want the tool chain that you use in that environment to be cloud hosted as well. So there's basic just management and deployment stuff there, but then also development that goes on there as well. Once you've kind of laid out the table with these like fancy new tools and all these cool capabilities, there's another type of user that, how many people in this room are developers? Actually, I'm curious. Right, okay, so almost everybody here. So these are generally the users that you service on a day-to-day basis. This is the HR, finance, or legal user. They might even be in IT, and they're aligned with these lines of business, but they're going to come to you with requirements of we need to integrate this or that, and then as a developer, you're going to go and do awesome stuff as developers do, and you're going to deliver this service to this developer, or to this line of business user. Turns out, like those users, they actually know the business processes very well. They understand the business data. And so they know like they can define the requirements for integration. They just don't have any tooling to do it. So wouldn't it be cool if we gave them some tooling, got them off your back, so you could even focus on more cool stuff, like microservices and function and lambdas, right? That's cool stuff.
Absolutely.
Yeah, we'll hear about that in a minute. All right. Next piece is how you actually deploy any of this, right? So is this going to, you have existing CI/CD infrastructure, you're using Maven to build today. How does this all line up with what you're doing? Is it some like foreign build system because it's in the cloud? Another kind of important consideration of IPaaS. And then finally, is this IPaaS thing, what does that mean? Like now I have IPaaS developers and now I have on-prem developers too. Like, are they completely different environments? Most teams don't have, even though most companies we talk to are pushing aggressively towards public cloud, they're not going to be 100% cloud tomorrow or next year or maybe ever, right? And the definition of what it means to be public cloud is different between these customers as well. Some of them think, well, it's just infrastructure that's in the public cloud, but I'm managing everything on my own. And some customers are like, no, I'm getting out of that game completely. It's all PaaS, I'm totally in on that, and I just want to do pure app dev, right? So lots of different considerations there. Okay, so that was kind of like the boring, businessy kind of stuff there. And it turns out, like, okay, that's my flowers and puppy dogs pitch for IPaaS and why it's great. But there turns out, from a developer standpoint, there's a seedy underbelly, like a dark side, you might say, represented by the Mos Eisley spaceport there, of all the stuff that sits underneath an IPaaS that, there's other IPaaS products out there today that it's essentially hidden from developers. And of course, these are technologies that we have upstream and Fabricate that we're working on from a product standpoint. And those are the things we want to talk about today because they're super cool. And there's reasons why you want to know about those things because they shouldn't just belong behind closed doors in a public cloud solution. You should be able to use those on-prem and in the public cloud. All right, so real quick, this is a little, Rob and I can get interactive here, but there's 3 considerations from a development standpoint, all right? First is building the application, which is necessarily different in a containerized cloud-based architecture, right?
Absolutely,
yeah.
It is.
So oh, sorry, go ahead, Rob.
Sure.
No, no, I thought you were going to say something. I just didn't want to interrupt you. Okay.
Yeah, I was actually.
Okay.
Yeah, so when you build things for containers, key thing is it's not got to change. It's got to be immutable, basically. So that adds a layer of complexity in how you actually build things.
Mm-hmm. So, we're talking about Docker containers here, right?
Yep.
We're talking about, we're hearing a lot about how monoliths are super bad, right? We don't want monoliths. We want microservices. This is good, right? Yeah, that's good. So, well, that sounds cool, but that means all aspects, all of these services are independent processes, right? They're all in their own encapsulated environment.
Absolutely.
So can I use NVM endpoints in Camel for that now?
Not really.
Okay,
That's going to fail kind of bad. Yeah.
So maybe go back to the monolith. You don't have to go back to the monolith for that. But there's these, and then also I guess another consideration is does the tool chain different, right? Is it like Camel's a great framework? I use it on-prem all the time, right? Is Camel no longer relevant in this kind of picture because it's an on-prem technology?
Absolutely not, no. Actually, when we thought about doing the IPaaS, it would have been a lot easier if we did take a kind of like a monolithic approach for each customer. We deployed everything inside one container. But the downside of doing that is horizontal scalability, which is why everyone is so interested in microservices. We need to be able to break out services as independent, scalable components if we're going to be able to scale out to the demand that we need to meet for some of our customers' applications.
So this really needs to enter your consciousness right from the beginning when you look at any cloud-based deployment environment, right? You don't have to, now I'm saying you need to think about these things, but it doesn't mean that you have to adopt some very rigid architecture like there's 12 factors to an application. You must do all these things, and if it doesn't fit in there, it's no good, right? It's a spectrum, a continuum, right? And we can accommodate all of that. All right, next thing. So how you actually deliver these applications. So I referenced this on the last slide. We've created it, right? We've got it all broken up, right? Now, like, we know it's a Docker container, but like, isn't there like a way? Like, what if I've got a CI/CD build, or like I've got Jenkins today, right? Does that mean that I can't use that anymore? Like, that's my corporate standard. Is there a way to integrate that in this environment?
Yeah, absolutely. So we've looked and done various research on different things around integration, continuous integration, continuous delivery. Jenkins is the most popular choice, so it made sense for us to actually reuse Jenkins, and we use the Jenkins plugin to enable continuous delivery inside the platform that we have, which we'll be talking about more later.
So the third piece is, like, everything works with Hello World, right? Like, we talk to customers, and it's like, and you talk to the ops team and the dev team, very different, perspectives on what application development is and what support is, right? DevOps certainly trying to get more on the bandwagon of the dev team carries a pager. You're responsible for how these things perform in production. And if that matters to you now, then it's not just a validation of, yes, I could write Hello World and deploy it locally, and we're all good. Now you have to start thinking about, hey, what if I need to, like, this gets really popular because these apps we're writing are going to be cool, right? People are going to start using them. What's the scale out for that, right? Now do I have to rewrite the application to scale, or does it just kind of scale naturally, right?
Yeah, and it's got to scale naturally. It's got to actually scale out based on criteria which are external to the application.
Right.
On metrics, for example.
Yeah, exactly. And another piece of this is, do I think some people are just magical, right? Especially I think in the drunken deploys to production are the Silicon Valley, kind of the holy grail, perhaps. But for, most mortals, you don't get it right the first time, right? So and especially in kind of an agile DevOps microservice type of environment, you're trying to iterate quickly, right? Get something out there, get some feedback, iterate, iterate, iterate. And to do that, again, with microservices, an application is not just one deployment, it's many deployments. So what tools do you have at your disposal to do these independent deployments and not have it break your entire application architecture? All right. So quickly, just to give you an idea of where we are before we transition, and Rob will talk a lot more about where we're going. So in December of last year, we released a Fuse on OpenShift, which we call Fuse Integration Services. That actually runs on OpenShift Enterprise, which is our private cloud container application platform. But it also runs on OpenShift Dedicated, so that's another, if you're not familiar with Dedicated, it's like Enterprise, but Red Hat hosts it for you in the public cloud. So again, going back to cloud-based IPaaS, we set it up, we install it, we keep it busy, we keep it company, make sure it's not lonely. If there's any issues from the OpenShift cluster standpoint, we take care of them. You come in, you just deploy your apps on top of it. You maintain your own apps. So completely cloud-based solution there. We have the best of private and public cloud. And principally, the thing of principal importance there is that it's the same stack. So Red Hat supports it from Linux all the way up to your application. And it's not just in the public cloud, not in the private cloud, not different techs. It's all the same tech, whether it's private or public. Very, very important. Unless, of course, your company is just going to stay private, forever, or maybe just go to the public cloud tomorrow and never look back, which is cool too. What else? We should talk about some of this other stuff on the slide. It looks important. So one thing we did with Fuse Integration Services, we didn't just pick up Fuse as a platform, all 900 megs of it, and drop it in a Docker container and be like, done, high fives. That's like a Top Gun high five, right? Up, top and bottom. So we realized that, hey, we talk about these things like microservices. Folks don't want that. Forget about, I don't think the size really matters that much in terms of containerized applications. I think what matters is the surface area of what you're supporting. And if you have a Docker image that has the whole world in it, the surface area of what you're supporting is very large, right? Right?
True.
OK, thank you. I like this affirmation. Makes me feel better about myself. So, so what we decided is, hey, let's go, I shouldn't say what I decided, the Fabricate team and the Fuse team decided, because they do good work. Let's start with just the bare essentials in our base container image, and we'll look and introspect inside your application and only pull out the dependencies that you need and bake those into the Docker image that gets deployed, right? So your application is, your container that your application runs in is a bespoke build of Fuse every time with just what you need. So that's just from the Docker standpoint, the container standpoint. We've also natively integrated with Kubernetes, so which is actually pretty easy because Kubernetes is pretty friendly to work with, right? You just give it a host name, right?
Absolutely.
Look it up, yeah. But we actually have some components that are in there that, like the ActiveMQ component, it's modified so it works. You can give it, it's wired into Kubernetes, right?
Yep.
We have templates, and we can generate OpenShift configuration and Kubernetes configuration to actually register the services. So for in Kubernetes, if you're going to invoke, remember, these things are deployed as a single process. You need to expose out of that process what functionality you want other people to invoke, and that's done through a Kubernetes service. And so some really cool tools in Fabricate and FIS for generating that configuration and tweaking it and just exposing the services that you care about. And then, of course, on top of all that, the good tooling that OpenShift has around management, we plug in the management console, and then with source-to-image builds, we integrate with that as well. I think I managed to step on every other, I thought I was talking to the first bullet, but I think I covered them all. All right, so real quick here, just finishing up. I don't want to take all of Rob's time.
No, please do.
OK, absolutely. Do we mention there's beer later? Is that, okay,
yeah, we've
right.
mentioned that several
Okay,
times.
so to give you an idea here, just these are some nice pictures that go along with what we were just talking about. So starting from left to right, when you, again, going back to building your application from just the components you need, you just start with a template, right? You just start with a Maven archetype, and you say, give me this type of project. Now you got a new empty application, maybe some starter stuff in there. You fill in your code and config, and you run a build. It pulls in that Docker image that's the base of your application. Remember, in Docker, you're pulling in, it's a complete closure around your runtime environment. So it defines the OS to the JVM that you're going to use, to the Fuse bits, including your application and the code and configuration you have on top of it, right? So what this build is doing, whether in source to image or locally with the Fabricate Maven tooling, is it's actually building that whole container image by taking that base Docker image we define, pulling in all your dependencies into the next layer in that Docker image, and then laying your application on top of it. We talked a little bit about cloud connectivity and the Kubernetes service registry. So again, when you're actually creating these applications, the services are auto-generated for you. So they're automatically exposed from your application. And that allows you to talk in between applications. And one of the things I think is overlooked when people talk about microservices architectures is the function of, like, depending on who you're talking to, some people call this the API gateway. It's the function in a microservices architecture that makes it so that consumers of your application don't care that you're running a microservices architecture, because they don't, right? The fact that you're running microservices is your business. It's a better way for you to deliver functionality, but that doesn't mean that someone has to write a mobile client and now they need to know about the 50 backend microservices that drive that application, right? They want a single thing to hit. And Camel is an awesome technology for tying that together. So you can create a Camel route that's just talking to Kubernetes services, which are just host names, and wire them all together. It's just straight HTTP type of traffic inside of OpenShift.
In fact, Camel is perfect for microservices.
It is perfect.
It is.
I'm glad you said that, Rob. I've been considering that, but no, I agree. It is perfect. All right, let's turn. Enough silliness for me. Turn it over to you.
OK, so you have to shuffle this way.
OK.
Thank you.
Wait, this?
Yeah.
No. Oh, sorry.
Yeah. OK, so we take a step backwards about what we're trying to do. And actually, I guess most of you are Fuse users and you've used Fabricate version 1. When we started this kind of journey to build this microservices platform, well, it wasn't called that at the time. What we wanted to do is actually have a platform which would provide things like a runtime registry, because you actually need a runtime registry. We're actually building services, and we've no idea where they're going to be deployed by the platform. So you actually have to go and look things up. You also want the platform to provide logging, security, and ideally do the deployments for you and control scalability. So if you're using an application server, it used to be the case of the application server used to provide all that infrastructure. Now we're expecting the platform to provide that infrastructure. And that's not a difficult concept to get your heads around, because if you have more than one application server, typically you'll be clustering logging around these. You'd have centralized logging, centralized metrics for collecting information from all your application servers if you're running 2 or 10 or 100. So actually taking those concepts out and having a common platform that you can get that information from makes a lot of sense. The other thing that microservices do as well, if you start to adopt microservices, is there's some things that you actually have to build into how your microservices are coded. So they have to be loosely coupled. They also have to be resilient. So your service, if it's calling another service, has to take into account that service could disappear and reappear at any time. They also have to be temporal, and by that I mean that when a service comes up, it's going to have dependencies that it relies on, and it can't guarantee they're going to be up when it's running. So that resilience has to be built in, and it'd be really nice if that was built in for you. So that's something that we've done in the Fabricate project around the use of Camel. We've built in checks, and I'll explain some of the technology we've used to enable us to do this into the actual foundations. So what we're doing actually for IPaaS, and we're calling this IPaaS 2, is because we took a fundamental look at what we needed from the platform if it was going to address the kind of problems that we want to for our customers, i.e. horizontal scalability. It's something which you really need to have good foundations for. You need a great platform for that to work on, and you need the right technology to use. We've already said Apache Camel is ideal for microservices, because you can be very constrained about what it's actually doing. It's going to do one thing very well. And it's also a library, so it's going to have a small footprint, and it's very straightforward to deploy. And there's lots of different options that you can use for deploying Camel. It can be deployed in an application server. But for this particular case, we're going to be using Spring Boot for deploying Camel. There's also already great integration between the Camel project and using Spring Boot to start up your microservice. And on top of that as well, we've also built in the tooling, the Maven-based tooling, so we can take a project that you use and then not only deploy a Camel route, your Camel context and all your routes into Spring Boot, but we can take then that Spring Boot executable and then wrap that inside a Docker container and then deploy that onto the platform. And the platform we use...
Actually, sorry.
Sorry?
Oh, no, I want to... Okay. I decided I like talking, so I want to go back to talking a little bit more.
Okay.
Can you... All right. Is this thing on? I turned it off.
Yeah, it's on.
All right, now we are. So you raised an excellent point there about IPaaS 2, right? And why I totally forgot to kind of dereference that and like why we called it IPaaS 2. So that's kind of important. And the reason why is not because, well, I guess it's nuanced. One is that I made reference to Fuse integration services, and we shipped that last December, and that provides a core foundation for IPaaS, right? Not all of what we want in IPaaS, but the core technologies that we've been talking about are shipped and supported by Red Hat today, available public cloud and private cloud. But the other aspect is we looked at the IPaaS market as part of this, and we said, we can do better. There's a next generation of IPaaS that's coming here that's not, that engaging the citizen user, having these higher level interfaces is super important, but that does not mean leave the developer behind, right? Developers want cool stuff, they want great technologies, they want the ability to help out these citizen users, and when things get, maybe integration is simple sometimes, but it can also get complicated, as we know, right?
Absolutely.
We want those expert users in the picture to help those people out. Yeah.
Perfect. Thank you, Keith. Okay, so you probably have heard a lot about Kubernetes already, but it's when we started off with Fabricate version 1, we were trying to build this stuff ourselves, and luckily Google came out with Kubernetes a couple of years ago based on the experience they had in-house They open sourced Kubernetes, built around concepts that they've been using for over a decade. And it's perfect for deploying and managing applications. It's a perfect foundation for a platform that you want to use and deploy microservices on. Now, as you know, OpenShift is an implementation of Kubernetes. And this is what IPaaS is going to be built on top of. And OpenShift provides ways for application development. You may have seen some of the sessions around here about using continuous delivery. And if you saw James Strachan's and James Rawlings' excellent talk earlier on today about deploying, doing continuous delivery on top of Kubernetes using Fabricate, you'll know that is one of the foundational things we're building into the IPaaS. So we're taking up the Jenkins, which is available in OpenShift. Now, today, adding plugins around that, and that's going to be part of the OpenShift 3.3 platform. And then we're building on top of that again. We have to build in things like project wizards, Git repos, and Nexus repositories, so we can deploy applications easily onto our IPaaS. And in fact, what we're actually building is a microservices platform. And we're building that on top of OpenShift. I mean, additional things we're providing on top of that, I'll go into in slightly more detail. But as I've already said, what we're going to be doing is deploying fundamentally Apache Camel deployed in Spring Boot in Docker containers. So if you take a look at the architecture that we're putting together, at the bottom is OpenShift dedicated, and Keith's already talked about this. It's OpenShift managed by Red Hat, deployed on Amazon EC2. Then the guts of what we're doing and building out is the middle portion of that slide. So what we're doing is we're going to be exposing those individual components to what we call expert developers. So the people who are kind of using Camel today, who will understand programming and what we're doing in terms of building out tooling that they will need to help the citizen users be successful. So these are things like code quality, the Git repository, the application metrics, which I talk a little bit about, project wizards. So when we're starting off, you can decide if you're what kind of projects you're going to use, what Maven artifacts you're going to use to deploy certain components. I'll talk about the circuit breaker too. The thing I'm not going to talk very much about at all, actually, is the stuff on the top, which is for the citizen developer. And this is all currently being built right now into a web UI, which will provide the ease of use around the tooling for people to create easy integration flows, which are then deployed onto the IPaaS.
We should talk about function a bit, though, yeah? No?
You can do that.
James will be happy.
Yeah, I can talk about that.
All right.
I'll talk about that later. Okay. So the first thing we're providing actually in terms of IPaaS, and we're actually building this out on top of OpenShift. Think of IPaaS that we deliver as a black box. They're going to be components that we're actually wrapping inside the IPaaS platform that over time may actually get delegated down to OpenShift. So this will happen. And the reason we're doing it this way is because OpenShift are on a particular trajectory. We know where their roadmap is. We know they're going to be introducing more application logging inside OpenShift. And we want to reuse that. But that's going to be probably a good 6 to 12 months off before they get to a stage where they can provide the application metrics that we need. And if you're deploying any applications, actually being able to follow what's happening with the applications, being able to debug what's going on, you actually need to collect all the logging information. So what we do is actually one of the infrastructure components that we are going to be reusing from OpenShift, and OpenShift already supports this as a core component, is the Elasticsearch. So we collect all the application metrics from Camel deployed, and we then push them out to Elasticsearch, using FluentD for collection. And then we've got Kibana, which we use on the front end to actually present those logs to the end user. So we broke all these things. As we've broken down the roles into citizen developer and the expert kind of users, these are things which we might not necessarily expose to a citizen developer, but we certainly expose these to expert users. Sorry, Keith.
No, sorry, I didn't mean to. I was just going to, to poll the room here. Who's using ELK, EFK stack today? Just out of curiosity. Okay, right on.
Okay. That's cool. I'm very much like application.
Oh, question, yes.
Whoa. That's a good question. I think yeah.
Do we have a third mic?
Also remember, we're going to be supporting this for you initially, because this is on OpenShift dedicated. For the IPaaS, we want to support all those components on your behalf. And that's something we haven't considered third-party like logging components, for example. So that means that we'll be supporting Splunk on your behalf, and yeah, I'm not sure we can.
Yeah, I agree. Do you think, but I wonder, is there another dimension to that, which is just if you're using another tool, it's self-managed, but there's an interface, like an export-import interface or some kind of wiretap or something you can do it's an interesting, because I mean, everybody's got their own management model.
Yeah. You just want to get the logs out. Yeah.
Oh, yeah.
Yeah. Yeah. Yeah, because you can chain FluentD, can't you? So you can go to more than one output. So, yeah, you can certainly do that.
Do we have another mic that we can pass around, maybe? Uh-oh, I stepped out of the box now.
You no longer exist, Keith.
Yes. You can go ahead.
Oh, okay. All right.
I was going to walk around the crowd.
All right. So the other component we provide as well in this platform is going to be application metrics. Just like application logging, it's important for being able to debug and actually understand the performance criteria of IPaaS, so it's application metrics. And what we're using here internally currently is going to be an open source project called Prometheus, which came out of SoundCloud in 2012. And it's built by the guys who built the internal metrics used by Google. So this is a very popular project, but again, it's a black box component. So we're currently using this today, but this is functionality, again, which is going to be delegated down to OpenShift. So when OpenShift, the product, has support for more application metrics that we require, we delegate down to the OpenShift platform. For users, they don't really have to care how we're implementing this. We're only mentioning this to you because it's DevNation. So we want to talk a bit about the implementation details. But for the end user, all they care about is like just a black box on these are criteria and functionality that we're going to be providing to add value to the platform. So as well as logging and metrics, another key thing you want to be able to add in is tracing. So if you're doing a call from one microservice to another, so imagine Camel is calling another component, which is calling another component. You can get bottlenecks really quite quickly, and it's quite hard to debug. So a lot of these tools that we're providing are actually to enable expert users to debug and fine-tune how the IPaaS is actually going to work in practice. We're using Zipkin, for Zipkin distributed tracing framework to enable this to happen. And we've got a console built into the IPaaS console. And Zipkin's an interesting project. It's a passive way of collecting data. So it just sits there, and your application has to throw the information at the Zipkin architecture. This is already built into Camel. So there's a Camel Zipkin component, which is in Camel 2.18, which we're going to be using in the IPaaS. Now, that doesn't mean that we're shipping Camel 2.18 with the IPaaS. We're going to be backporting that component into the Camel project. And if you look at the...
Can you hear me? Uh-oh.
Hi, Keith. There you are.
Yeah? The question I was going to ask is, I'm curious who's using Zipkin? Because this is a class of, I know, you use everything now. And if there's not something there, you write it. So, okay, that doesn't count. Anyone else using Zipkin, just out of curiosity? And then Hystrix is the other thing. I'm just curious within the Netflix OSS stack. Given. Yeah, okay, all right, good.
Are anybody using any other so Zipkin's one particular flavor of a tracing framework. Is anyone using anything else? Or is it not some... Yeah, that's true, App Dynamics. So I think these are the things, like tracing is something which becomes more important for you to consider when you're using microservices. Microservices do throw up these complexities into the architecture because everything is distributed, everything is remote. To be able to debug and trace and see what's going on inside your architecture, you do actually have to have more tooling. And if this is provided for you by the platform, it's all goodness. The other thing that we have is API management. Now, there was just a talk done at Summit that Keith did with the Freescale folks. So API management, as Keith will attest to, is very important for the IPaaS platform itself. Now, because Red Hat's just acquired Freescale, that means that our roadmap is going to have to change slightly to accommodate the adoption of API management in IPaaS. But over the next couple of weeks, months, we will get more information on that, won't we, Keith?
Sure. I mean, we can talk a little bit about it now, which is that ultimately, I mean, this is a good time to talk about Kurt's work maybe upstream in Kubernetes, right? And annotating, introducing the ability to annotate kube services as APIs. Okay, so one of the developers on the Fabricate team, everything is exposed as kube services. So when applications interact or services interact within OpenShift or a Kubernetes environment, they're going to use Kubernetes services. And they recognized how important APIs are in that architecture as a first-class citizen and allowed metadata, which is not an easy thing to get added to Kubernetes as a standard. That community is pretty picky about what it allows upstream. And so they recognize the need for this, and now you can mark services as APIs. So in this architecture, we've already done a lot of work here with Eric, Kurt, and the API Man team for understanding how API management looks in OpenShift, right? All based off of kube services, marked as APIs, and being able to deploy the gateway independently to basically proxy and manage the lifecycle of those APIs independently.
So one of the annotations that Kurt's added to Kubernetes is to different microservices have different ways of exposing Swagger or Waddle or WSDL or whatever standards they are. There's no canonical standard of where the Swagger should be. So one of those annotations that Kurt added is a standard annotation that if you make a Kubernetes service and it has Swagger inside, you can annotate where the Swagger is so we can generically collate that and we know what the Swagger is. So the API Man console can visualize the Swagger in any service in Kubernetes. Another one is the web context, where you might deploy an app. Okay, sometimes slash is how you access the website, but sometimes you have a web context, like a path that you have to get. It's not just an IP address, it's an IP address and a path to get the thing. The web context is another standard annotation. So we can annotate a Kubernetes service to say, where's the Swagger, where's the web context? So generically, we know how to work with the service. And then we can tool that with a nice tool that can visualize what does the Swagger look like, what does the API look like. You can then invoke the API in a web console, and we make things kind of easier, right? So that's two annotations. Yeah.
Actually, James.
So it's sorry, Rob, you were going to make a point.
Yes, so I was just going to say, but okay. So the next topics I'm going to cover are CD and then Functon. Why don't you give James back the mic and he can come up here and talk about them?
Oh, it's well, wait. So
5 minutes.
5 minutes. Oh, okay.
So we've got time for Q&A at the end.
Yeah, fair. Okay, let's keep rolling, and we can if
Sure.
there's no questions, we can get.
Okay. So the other thing that we build into the platform is, and James, if you saw our talk this morning, which was excellent, it's all about continuous improvement. If you look at the stats, which are used from companies which are delivering all the time, they have much better quality software. If you're slowly delivering software and you've got long release cycles, for some reason you have more bugs. So this is something which goes hand in hand with microservices. So we want to build it into the IPaaS platform, reuse the functionality which is also already in OpenShift, but build on top of that as well for IPaaS. So we can take the services which are defined by citizen developers and then push them through test cycles. We can automate a lot of the testing for them too, so we can validate that any services they provide are actually going to work. We can put in stubs to make sure they're calling the correct APIs, and then making sure they deploy correctly and they interact with other services that they're calling in their IPaaS deployment. And by adding this CD pipeline in place, it's one of the criteria that makes the IPaaS that we're developing right now into an IPaaS 2 kind of thing. I mean, it's unique for the marketplace, so it's great.
By the way, I think we have a decent amount of time. It ends at 5:45, right?
Yeah. But
So I think the timer
questions.
started early, so 17 minutes left.
Yeah.
Yeah.
So the other thing I really wanted to introduce as well is this isn't for citizen developers. This is for expert developers, or maybe like the next level down. So you don't have like ex-citizen developer and an expert developer. It's going to be a continuation of expertise that you have. This is something that James Strachan wrote. It's event-driven Lambda-style microservices built on top of Kubernetes. So it's really straightforward and easy to kind of use. And underneath the covers, it's actually using the power of Apache Camel. So you've already got all the hundreds of URLs which are built into the Camel framework that you can invoke. And all you have to do to define a function is to actually either edit a YAML file, and this is an example YAML file for a function where you define a rule, the trigger, and the action. And the action is actually just a piece of Java code. Now, you could also do that in other languages like Groovy and Kotlin and Node and Go. Is there any other ones, James? That's it. Yeah. And then deploy it. And actually, James is going to be doing a blog post about Functon, and there's also a console piece coming with it. So if you don't want to hack by hand and actually define the function itself in a YAML file, there's also going to be a UI-based editor to define these. The fact that these are event-driven lends itself really well to like an IPaaS platform, because basically Camel is really an eventing engine. It's based on events which come into Camel or it's polled for. Functions act in the same way. But underneath the covers, what the Function project is doing is actually taking that definition of a rule, it's wrapping that up into a Docker image and deploying it into Kubernetes and doing all the wiring, all that hard work that you normally have to do to get something deployed into OpenShift. It's all done for you, and it's very simple and straightforward to do. Now, I talked a bit about all the infrastructure components that we've got underneath the IPaaS. There's quite a lot of detail as well I've missed out. So I haven't talked about Hystrix or the Kubeflex project that we have. I haven't gone into the automated testing. I haven't talked about ChatOps, These are all things that we want to expose on iPaaS for expert users. But actually, underneath, there's a lot of infrastructure we've put in place. But all the citizen developer is going to see at the end of the day is something like this. A nice UI, which is going to define actually how to build out a particular service that they're going to be deploying onto iPaaS. So that's the end of my presentation. And Keith, do you have anything you want to add?
Well, I think that was that's good questions. If there's questions first, because you hit on actually some other awesome stuff to talk about that we can just, freestyle on, and there's other great stuff. But we do want to give a chance for questions. So does anybody have any questions? Yeah.
Well, nothing happens to Graph. It's still there. Yeah.
Yes. Yes, so great question. Yeah, you can. So with Fuse Integration Services, it is supported today and continues to be supported. It's just that the nature of Graph, it changes really in immutable architecture, right? For two reasons. One is that because it's immutable, like you collapse this Docker container, if you make a code change, you recreate the container, the whole thing. You throw out the old one away. You don't live update it at all, right? So OSGI, one of the great things about it is that you can live update stuff, right? So when NASA's flying to the moon or wherever, you're like, oh, maybe just a quick fix, not like throw away the shuttle and send a new crew, right? So that's one aspect of it. And then the second aspect is class path isolation in Graph and OSGI. So if you have a very large class path, you might want to control what can see what, right? And OSGI is very good at that. But the thing is, depending on who you talk to, that could be an anti-pattern in microservices-based deployments where you want smaller deployments that you update more frequently instead of a really large deployment that pulls in tons and tons of dependencies. So, OSGI becomes a little bit less relevant, but still really relevant to our customers because they have a bunch of Fuse apps developed on Graph with Blueprint and other technologies, and that's why we support it to help customers move over.
So our current thinking on this is Fizz supports Graph, but if you want to develop an integration service which you can deploy on premise using Fizz, and then deploy the same thing onto the IPaaS side of the house, that has to be deployed in Spring Boot. I'm not correct. Sorry?
Yeah, absolutely.
Yep.
James, you might as well come up here. Yeah, and it's gonna be super funny because we all have to stay in this little box to stay on camera, so we can. Let me just take this off, and you can hold it.
Where did the mic go?
I gave it back to him.
We'll see. All right. Okay, so there's lots of ways of doing things, right? Some people like OSGI, some people like Spring Boot, some people like Java EE, some people like Tomcat, right? As Fuse people, we don't really care what you want to use, right? Or to say that a different way, we want you to use whatever the thing is you like. If you like Tomcat, fill your boots. If you like Java EE, go for Wildfly Swarm. If you like Spring Boot, go for Spring Boot. Our recommendation is Spring Boot because it's the simplest thing you could possibly do to do integration solutions. That doesn't mean Spring Boot is better than Carafe or Java EE or whatever. Our preference is to use the simplest thing you can possibly use to get the job done, which is flat class path, Spring Boot. It's really, really, really simple. However, we're always going to support Carafe, we're always going to support Tomcat, we're always going to support Wildfly, we're always going to support OSGI. But Spring Boot right now is the simplest thing we can think of. Now, some people love OSGI and that's cool. Some people love Java EE and that's cool, and Wildfly and whatnot. So really, use whatever you want to use, quite frankly. It's all cool. However, at the same time, with the move to microservices, the simpler a thing is, the easier it is to get stuff done, right? OSGI is a bit of a Marmite technology, right? Some people love it, some people hate it. It's kind of complicated. If you're just making little microservices that just have small amounts of code with a fairly simple class path, it's maybe too complicated, right? And it may be easier to use Spring Boot. That doesn't mean we're moving away from Carafe and we're going to kill it or anything. We're going to support it for decades, right? Well, at least a decade, maybe 2 decades. From a
product management standpoint, we prefer to say sophisticated. Not
yes, okay, sophisticated. It's a really sophisticated tool, but that doesn't mean you need to use it for everything, right? Yeah. So it's about choice. So I think that I'm rambling already, and I apologize, but what I'd like to say is, if you want to use OSGI, knock yourself out. Go for it. If you want to use Java EE, knock yourself out, whatever. our preference is now Spring Boot, but that doesn't mean it's better. It's just it's simpler. But that doesn't mean you have to use it, right? Use any of the things. It's all going to be fine.
Giraffe's in the picture forever, basically.
Exactly. So
yeah,
use
no,
whatever.
Just because we didn't specifically reference it, it's
Yeah.
not because it's on the way out or anything.
And the most important thing is all of your bundles you've written right now today will work immediately in Fuse 7 and the IPaaS and yada yada, because Caraffe's always going to be there. I was going to make one other point about Caraffe, by the way. Right now, if you're using Fuse 6 and Fabricate V1, the way it all kind of works is you boot up a container and it's an empty Caraffe, and it talks to Zookeeper and says, what are the bundles I need to load right now? And then it dynamically turns itself into the profiles you tell it to be, which is okay. However, in the Docker world, it's kind of better just to bake an image that knows what it is. So in the Fabric V2, even if you're using Caraffe, we bake a Docker image with just the bundles you want to run. So at startup, bam, everything's on disk. Like, there's no downloading jars or from Maven repo at runtime and crap like that, right? We bake a Docker image, which is exactly which OSGI bundles you want to use. So the Fabric V2 way of using Caraffe is way better. Now, okay, technically OSGI people like everything to be dynamic and wacky and updating on the fly and whatnot, which is fine in development. That's awesome. But in production, you probably don't want to do that. Updating bundles on the fly in real time is kind of scary shit, right? Nobody quite knows what's going to happen. Like starting and stopping concurrent services in OSGI is a kind of complicated problem. What's cooler is a known startup order that you know it's going to start bundle A and then B and then C and then D in a nice simple sequential thing. In other words, if you want repeatable, reliable production, you want to bake an image of Caraffe so you know what's going to start up.
Absolutely.
So we're making, to TLD, too long didn't read, we're making Caraffe more reliable and simpler to use by baking an image of what you want to start up. So it starts up faster, we can validate at build time, it's going to start up, all bundles are going to be resolvable, all features are resolvable, and yada, yada, yada. So we're making OSGI better, but it might feel like we're moving away from OSGI because we're not doing the same dynamic stuff in production. But that's a good thing. It's a good thing. Sorry, that was a long answer. I apologize.
If you're deploying in the traditional way you are, like on-premise, you're not deploying on OpenShift at all, then just use Caraffe as usual. That will be supported.
But even for mixed mode deployments, you could use it for on-prem, and then you could also use it for, I mean, that's one of the benefits of our strategy is that you can use it in both areas. It's
Yeah,
like
absolutely.
Yeah, so it's
Yeah.
cool. Diraj, you had a question or a point to make? Yeah. Mm-hmm. Yep.
Yeah.
Yeah. Right. Yep.
Sophisticated, I think is the term. So it's more sophisticated.
No,
That's true.
A great point. That there's technologies on the horizon that also we're going to see. But for right now, we want to support our customers in deploying what works best for them, and there's nothing in this architecture that prevents that. So.
And in the old days, you'd have really complicated class paths, and you'd have like 3 versions of Spring in the same JVM and shit like that. In the microservices world, you think, let's have 3 microservices. Like, do we really need 3 versions of Spring in the same JVM? That's kind of insane. So in some ways, the microservice way is an alternative approach to OSGI, which is cool too.
Yep.
But it's all cool. Like, use whatever works.
So any of, yeah.
Sure, that's a great question. Yeah.
Keep.
Oh, thanks. Okay. So yeah, I'm going to play it back and okay. So the purpose of today's talk was essentially to introduce. We're working on this concept of IPaaS. We've released product to market already that satisfies a good portion of what a IPaaS is. What's missing is a citizen user experience
a hosted solution with a Git repository Maven, an optimized integration environment that provides the next level above just hosting OpenShift. We actually have a purpose-built IPaaS environment that citizen users can come, log in, integrate with a tool chain dedicated directly to them, okay? So that's where we're going next in terms of IPaaS, where we're going with Fuse integration services next. The other thing, and why it's called IPaaS 2, is because this level of mixed mode operation, being able to use that technology in the public cloud and use the same stack in the private cloud on premise, is something that no one else in the industry offers. They have agents that run on premise, or they have maybe like, a developer preview of something that might run on premise, whether that's the same stack or not. It's the same stack, all supported by Red Hat today in this picture, right? So that's kind of what we're talking about. And then Fabricate is, I don't think we specifically addressed this, but it's, this hotbed of technical innovation that ends up in all kinds of products at Red Hat. So the CI/CD stuff is ending up in OpenShift. Some of the core components that wired Camel into Kubernetes and OpenShift ended up in FIS. And now some other components are ending up in IPaaS itself. So yeah, and
some bits will end up in Fuse, right?
Yeah.
Sure, yeah. And then some just might stay in the community for a long time. I don't know.
Absolutely. We've actually been pushing bits out of Fabricate into other upstream communities like Zipkin, for example. We did a plugin for Zipkin to use with Fabricate, and we're pushing that back to the
Spring
Zipkin.
Cloud?
Yeah. Yeah.
Does that answer your question? Yeah. Okay, great.
You need a
PM.
guy.
So it's the FIS release. Hiram and I were just talking about this last night. The next release of FIS will be aligned with Fuse 6.3. So we'll look to do that in Q4 of this year. IPaaS itself, we're just after, like the week after next, we're doing the kickoff planning session for when we'll have the citizen user interfaces and that kind of thing. So it doesn't make sense to give a date right now. It's honestly, again, I want to stress that that's really an evolution of our IPaaS, right? That's a new user base that we can attract and help our expert developers that we have today engage with citizen users.
But the next phase should have most of the IPaaS, apart from the citizen UI, right?
That's correct. Yeah.
So if you're a developer, not a citizen developer, the next phase release should be most of the IPaaS.
Every phase will be better than the one preceding
Yes,
it.
it's all good. It's all good.
So and feel free, upstream these communities. It's the Fabricate community. That you can see all the development happening there of what gets pulled into both OpenShift and Fuse and various other upstreams, right? Yeah.
So I think we're just about run out of time, but just wanted to highlight the party we have tonight, which you're all invited to. You just have to pick up tickets from Red Hat booths. So this is mobile, OpenShift, or JBoss booths you see on the pavilion. They have tickets. I'm not sure where the location is actually even.
The location of the party or the location of the tickets?
Party.
Yeah, it's a Temple nightclub. Is that right? It's in the back of the flyer. It's right down the street, I think. So.
Right.
Sorry? Oh, it's Temple. Okay, yeah. So that's normally
Great.
a fun event. It's great. Everybody's there. Your fellow conference goers. Most of the folks from Red Hat will be there. So it's a great place to have some chats. Okay. Thanks very much, everyone.
Thanks, folks.
Sure.